Hey everyone, today we are going to be going over the 2019 FRQ number 3. That is the FRQ for Unit 4's review. If you have any questions that I don't answer here, I'm going to need you to go over to me someday and ask me, and I will help clear them up. So if we look at the start of our prompt, it says a student is given 50 milliliters of a solution of Na2CO3 of unknown concentration. To determine the concentration of the solution, they mix the solution with excess 1 molar calcium nitrate, causing a precipitate to form. The balanced equation is shown below, so they do that work for you, which is nice. And then for A, it says write a net ionic equation for the reaction that occurs when the solutions of Na2CO3 and CaNO3 are mixed together. Now, if you remember, net ionic equations leave out ions that stay the same. So if you have things that are aqueous on both sides as far as their ions go, those stay out. So if we look here, I have sodium and carbonate that are aqueous on my reactant side, and then calcium and nitrate. And if I look on my product side, the sodium and the nitrate remain aqueous. So those aren't going to be showing up in our net ionic equation. The Ca and the CO3 turn into a solid, so their phases change from aqueous to solid, and so we are going to see them in our net ionic equation. So I want to take the calcium carbonate and then the things that make up the calcium carbonate, and those are going to show up in my net ionic equation. Oops, sorry about that. All right. So what that leaves me is the Ca+2 ion, and it's really important that you have the charges correct on here, or you won't get the credit for it. Phases are not quite as important, but for now I'm going to put aqueous there. It's going to be added to the carbonate ion, which is CO3 with a -2 charge, and that is aqueous, and they are turning into CaCO3 solid. Okay, so again, net ionic equations leave out the spectator ions in there. For B, it says the diagram below is incomplete. Draw in species needed to accurately represent the major ionic species remaining in solution after the reaction is completed. At first glance, I look at this and I say, this is exactly how I would draw this reaction. So what is the problem? And in my mind, that's a trigger to say, hey, there is probably an excess reactant that they are asking about. And if you go back to the top of the prompt, you'll see that you have excess 1 molar calcium nitrate. So if we go back to our picture here, the calcium that's inside our reactant is going to be trapped in the precipitate, but we have an excess of it. And the carbonate is the limiting reactant, so there's no extra carbonate. So the calcium ion has to be drawn inside the solution as well. It's not a lot, there's not a ton of it because it is getting used up and stuck in the precipitate, but there does have to be some included in there. And that is how you get the second point for that particular problem. Okay. Moving on to part C. It says the student filters and dries the precipitate of CaCO3, and they give you the molar mass, so that's nice, and records the data in the table below. They tell you how much of the sodium carbonate, they tell you how much of the calcium nitrate, and how much of the calcium carbonate precipitated. It says determine the number of moles of Na2CO3 in the original solution. So I am given the, I think the issue here is that you are given two options. You are given the calcium nitrate and you're given the calcium carbonate, and you have to decide what to use for this. They're setting you up with two possible pieces of data to start up your stoichiometry to see if you know what you're talking about. The calcium nitrate, that is in excess. So we don't know anything about that. That is not relevant to this particular conversation because we don't know how much got used up. So we are going to have to use the mass of the precipitate to figure that out. So I'm going to start off with my 0.93 grams of calcium carbonate. And then you know from stoichiometry, once you have your starting information, you're going to go to moles. So they gave me my molar mass already, which was very kind of them. I've got 1 mole of calcium carbonate on the bottom and 100.1 grams of calcium carbonate are in 1 mole. So that gets me 2 moles of calcium carbonate. They give me the balanced equation at the top up here, and for every 1 mole of calcium carbonate, I need 1 mole of Na2CO3. So that's going to show up in my mole ratio. Okay, now I know that your first instinct is to go and keep solving until you get a mass or something like that, but be very careful when you read the problem. It's asking you just to go to moles. And if you look at your units with stuff that cancels out, we are in moles of sodium carbonate. So resist the urge to do more and just do your calculation. At the end, your number of moles is 0.0093 moles of Na2CO3. Pardon my bad writing there for the subscript. Okay. All right. Moving on to part D. It says that the student realizes that the precipitate was not completely dried and claims as a result the calculated molarity is too low. Do you agree with the student's claim? Justify your answer. So what they're kind of asking you to do is refer back mentally to question C, where you see that you created 0.093 moles. And so what they are saying is that because the precipitate was too wet, if you would have taken those moles and found the molarity, your molarity would be too low. So the question is, do you agree with them, and explain? In this case, if you have a precipitate that hasn't dried completely, you are going to get a higher starting mass in part C. So part C's mass here would be larger, which means that I would have a larger number of moles calculated for the number of moles of sodium carbonate that are used. And so I disagree with this particular student, because in the case of having a heavier precipitate, it would actually seem like your molarity was too high. So that's what I'm going to write. I disagree with the student. Make sure that you answer the question. So a lot of times people will explain the concept, but they won't actually go through and answer the question, and you don't get the point. So right there, you're going to disagree with the student. That is like the whole gist of that. If you leave this part out, you can't get that point. So I disagree with the student. Having a wet precipitate will lead to a higher number of moles of Na2CO3. If you have a higher number of moles of Na2CO3, sorry, the dog is barking at a suspicious neighbor. So if you have a higher number of moles of Na2CO3, those would lead to a higher number for the molarity. All right, so that is D. It says, after the precipitate forms and is filtered, the liquid that is passed through the filter is tested to see if it can conduct electricity. What would be observed? Justify your answer. So in this case, if they're asking about conducting electricity, you know that to conduct electricity, you need to have ions present. And if you go back and look at your beaker from part B, we've got a bunch of ions floating around in there. So it's basically a question about, do you understand how ionic compounds work? So it says, what would be observed? Justify your answer. So I'm going to say the solution would conduct electricity because there are ions present in the filtrate. Filtrate is just a fancy word for a liquid. So because there are ions present, you are going to see a conduction of electricity. Okay. All right. Now you'll notice that there are questions in this about net ionic equations so far, precipitation reactions with molarity, then questions about ionic compounds. So you can see that the format of these questions are super integrated, and I would expect the same on your test. So for part F, it says the student decides to determine the molarity of the same Na2CO3 solution using a second method. When Na2CO3 is dissolved in water, carbonate hydrolyzes to form HCO3- as shown by the following equation. So they give you an equation here and they give you a KB. Now they've agreed that they aren't going to be talking specifically about acids and bases on the test, so this problem is probably a little bit more specific, this part 1 and part 2. However, I think the ideas are easy enough that you should be able to answer them. So for they give you the equation for the hydrolysis reaction, and then they give you a KB expression here. Note that the KB is less than 1, and we know what that tells us. So for F, it says the student decides to determine OH- in the solution, then use that result to calculate initial concentration of the carbonate. Identify a laboratory method that's not a titration that the students could use to collect data to determine the OH. In my mind, the easiest thing to do would just be to use a pH meter to record pH and then calculate pOH and then get your OH- concentration. So the lab method, they don't say explain it, they just say to identify a lab method. So I would say use a pH meter to record pH. And that's all you're asked to do. It doesn't ask why, it just says find a method. Okay. Now, F2 here, I think, is probably a little bit harder than maybe not harder, but because they're asking you to use an OH- thing and they're not asking you to do that on the test, this might be a little beyond what your test will look like, but it's okay. So for 2, it says, explain how the student could use the measured value in part F1 to calculate the initial concentration of CO3- 2. And then it says, do not do any numerical calculations. So in this case, I would probably set up the idea of the math with this, but don't actually do any math. And basically, this is, do you understand how to use an ice table? So what I'm going to do is set up the ice table with my equation that's given. The carbonate -2 plus H2O at equilibrium with HCO3- and OH-. So that is the start of our ice table. H2O, you know, because it's a pure liquid, is not included in the calculations. But what they're trying to ask you to do is refer back to part 1. If we use a pH meter to calculate the OH-, that is going to give me the value for the E for hydroxide in my ice table. So let's say I don't know what my concentration of carbonate is. That's what I'm asked to find. Before the hydrolysis process works, I'm going to have molarities of 0. My change for the carbonate is a -X. The bicarbonate is a +X, and so is the OH-. The concentration for the carbonate is going to be a question mark -X. And then this is where understanding how the hydroxide concentration from part 1 is equal to X, you would say, oh, I know my concentration of OH-. And because they are both X for the bicarbonate and the hydroxide, the concentration of OH- is going to be the same for the OH- and the bicarbonate. Those are both equal to X, and they are the same there. And I think that's what they're asking you to do. Are they going to ask you a question like this? No, but it's probably good review. So I am just giving it to you anyways. Okay, last one. We did not have to do part H. So we'll be doing part G. It says, in the original Na2CO3 solution at equilibrium, is the concentration of HCO3- greater than, less than, or equal to the concentration of CO3- 2? And it says to justify your answer. This ties back to my original part of the prompt that shows me the KB value. So if you look at the KB value for this particular hydrolysis process, the KB value is 2.1 times 10 to the negative fourth. And you know that if we have a K that is less than 1, it is a reactant favored process. And if it's reactant favored at equilibrium, what that means is that we're going to have more of the CO3 minus 2 and less of the HCO3 minus 1. So what I need to do to fill that out is I need to, sorry, my dog is about to bark. So for G here, it says in the original Na2CO3 concentration is the HCO3 greater than, less than, or equal to the concentration of CO3 minus. We would make a note that says because the K of the process is less than 1, the reaction is reactant favored. This means there will be more CO3 minus 2 and less HCO3 minus 1 at equilibrium. Okay. Sorry for the disruptions. My animals are a little bit in my face today when I'm going through these keys. So if you have any other questions, I guess come to a meet. Otherwise, I think we should be good to go.